Hello guys, this is Dev. Today we are going to discuss previous year question paper for IIT and NEET in mechanics, and I have interjumbled the questions, so you don't need to look into separately which question is of which exam. You need to solve all questions, okay? Alright, so this is the first question. You see, the velocity of a projectile at an initial point A is 2i plus 3j. Read the question very carefully. It is given velocity is 2i plus 3j. Its velocity at point B is to be calculated. Okay, these are the options. Alright. So you see in this figure, V of A is given. That means the velocity at A is 2i plus 3j. Okay, let's assume this as x-axis and this as y-axis. Okay, so this simply is a projectile motion, and as I already told you, in a projectile motion the horizontal component Vx is always constant. Okay, the direction of Vx is always parallel to x-axis. Okay, be it here, for example, this is V, this is Vx, and this is Vy. Okay, and be it here, so this is Vx and this is Vy. So now we need to calculate velocity at point B. Obviously the net velocity is 2i plus 3j, right? So this means the velocity at B, the horizontal component would obviously be the same, because it is always parallel and always same. It does not change. The only influence Vy is getting is through gravity. Vx is not being influenced by gravity, and there is no air resistance taken into account. This means Vx has to stay constant. So this means Vb will be composed of Vxi plus Vyj, right? So this means Vx would be 2 because it is constant. So 2i plus Vyj. So now what would be Vy? You see, at point B, the object is falling down, just has fallen. This means gravity is not here. It is not acting here because it is the ground. Here gravity is acting. Here gravity is acting. Okay, but here it is not acting. Alright, since the speed will be same, this means the y component, the magnitude of the y component will be same, but its direction will change now, because y is pointing downwards, and obviously we know that I took I and j parallel to x and y axes. But if Vy is going down, this means this would be the direction and this would be minus j. So this means Vb would be equal to 2i minus 3j. Okay, because 3 remains constant, we have only added minus j over here. This was plus j. Okay, so this is the answer. Alright, so 3 is the answer over here. Okay, alright, so let's move on to the next question. Alright, so let's move on to the next question. It is written, first of all, you have to read the question very carefully. Okay, in these type of exams, question has to be read very carefully, because it is not a research oriented exam. The question always tricks you. Okay, a stone falls freely under gravity. Then it is written that it covers distances h1, h2, h3 in first 5 seconds, next 5, and then next 5 seconds. Okay, we have to find out the relation between h1, h2 and h3. Okay, alright, so this is the question. Ball or stone is dropped freely. First of all, this means initial velocity is 0. Okay, now we see that these are the distances: h1 in the first 5 seconds, then h2 in the next 5, and then h3 in the next 5. This is h3, this is h2. Or we can assume this as point O, this is P, this is Q, this is R. Okay, so OP equal to H1, PQ equal to H2, and QR equal to H3. So we have to find out the relation between these three. Alright, so first of all, I want to say is that we know the second equation of motion is S equal to UT plus half GT square. Okay, so now we assume this is downward y-axis, we have to take the minus j vector. Alright, because stone is falling down. This means the displacement is along minus j. This means we have to substitute S with minus sj, and U is obviously, I told you, 0, and G acts downwards, so this will be minus gj, and this is t square, right? So minus minus cancel out, jj cancel out, and we have S equal to half gt square. Okay, So what would be h1? It is very simple. Starting from O, we have h1 would be equal to half g into 5 whole square. This means 25, right? This is g here. So h1 would be equal to 25g over 2. This is h1. Okay. But I want to know what is h2. First of all, we see that in the next 5 seconds h2 has been covered. This means from O till Q, the net displacement is h1 plus h2, right? This would be equal to half g into 100. This is because total of 10 seconds has been taken from O to Q. So we are counting the net displacement, okay? We will not count the displacement from P to Q. If we do so, we will have to take the velocity into account, because from falling from O to P, the stone has gained velocity. And to make it simpler, I have taken this from O. And if we are to calculate from P to Q, we will have to use ut plus half gt square. Alright. Obviously, from O, u is 0, right? So v would be equal to g into 5. So at point P, the velocity at point would be equal to 5g, right? This means when we calculate PQ, this would be equal to 5g into t plus half gt square. Now this would be PQ. Now this calculation can get cumbersome. That's why I am taking the direct displacement from O to Q. So this comes out h1 plus h2 equal to half g into 100. Okay. Let me draw the figure again. This is h1, this is h2, and this is h3. This is O, this P, and this, this is OPQ, and this is R, right? So h1 was 25g over 2, and now h1 plus h2 would be equal to half g into the total time taken from in going from O to Q. That would be 10 seconds, and this would be 100. Okay, so h1 plus h2 equal to 50g. Now we can calculate h2 over here. 50g minus 25g over 2. h2 would be equal to 75g over 2. Now what would be h3? Obviously we are taking the displacement from O, where velocity is 0. So this would be h1 plus h2 plus h3. Now this whole expression is OR. Okay, this is equal to half g into the net time taken from O to R, which was, because this is 5, this is 5, and this is 5, this becomes 15 seconds. So the square of 15 would be 225, and obviously you know h1 plus h2 was 50g. So h3 would be equal to 225g divided by 2 minus 50g, and h3 would come out to be 125g over 2. Alright, so we can easily calculate the relation over here. You see h2 is 75g by 2. This means 3 times of h1, right? And h3 is 125g by 2, which is 5 times of h1. Alright, so this means h1 is h2 by 3 and h1 is h3 by 5. This is the relation. Okay, this is the answer. Alright, so here it is written h1 equal to h2. This should be h2 by 3, and this is h3 by 5. Okay, the second option is your answer over here. So the next question from the previous year is this. There are 2 points. You see Q is at 2i plus k and P is at 4i plus 3j minus k. Okay, we denote this as R1, as I already told you in my first video, and this as R2. Alright, a force of 3i plus j displaces the particle at Q and it moves on to P. So we have to find out how much the work has been done on the particle by the force. First of all, there is a very simple formula for work done. W equal to F dot R. Alright, because work is a scalar, the dot product is taken. Alright, work is not a vector, therefore the dot product has been taken. Had it been torque, it would have been minus of F cross R. Actually it's R cross F, so I have put a minus sign over here. Alright, torque would have been R cross F. So you see cross product is taken, that's why torque is vector. So you need to analyze this. This is very important because if this is dot, then tau becomes w. Alright, so we have to find out the work done. Now, work done, this r is displacement. So displacement is from q to p, right? So now let's see. This is r1, this is r2, and this is r. Alright. So according to vector triangular law, r1 plus r would be equal to r2, right? So r would be equal to r2 minus r1. This is qp. qp is the displacement of the particle. So what is r2 minus r1? We see 4i plus 3j, this is I, plus 3j minus k minus 2i plus k. So this becomes 2i plus 3j minus 2k, and this is r, and f dot r will become 3i plus j dot. Now this is work done. Alright, so what would this amount to? You see, I dot I would be 1, so 3 into 2 would be equal to 6. I dot j is 0, I dot k is 0, j dot I is 0, j dot j is 1, so 6 plus 3, right? And j dot k is 0, so w will be equal to 9 joules. Work done over here is 9 joules, okay? So we move on to the next question. You see, it's written that if f, v and t, force, velocity and time, are taken as fundamental units. You have to see the question very carefully. It is written fundamental units, and the fundamental units, this means it is equivalent to meter, second and kg, okay? This means we cannot take the original dimensions of f. We have to take it as f. So it is asking that then the dimension of mass r. Now we can see that force is the change in velocity by time taken multiplied by mass. Change in velocity by time taken is nothing but acceleration, and mass is m here. You see, this is only multiplication. This is not the cross product, because force is not a cross product of mass and acceleration, because mass m here is a scalar. Okay. So f is simply ma. Now it is asking the dimensions of mass. So you see, this dimension can be written as f, and m is change in velocity. So velocity change, v was the dimension of velocity, and time t. So f t by v, which is equivalent to f t v minus 1. This is the dimension of mass in this case. So this is the answer, okay? 4. This matches our answer, fv minus 1 t. This is the dimension of mass. Now we move on to the next question. This is a particle is moving such that its position coordinates x, y, r. 2, 3 at time t equal to 0, 6, 7 at time t equal to 2, and 13, 14 at time t equal to 5. The question is asking average velocity vector from t equal to 0 to t equal to 5 is. Alright. Now we have the figure over here. You can see, let us assume this is point P, this is Q, and this is R. At point P, the particle has coordinates 2, 3 at t equal to 0. Okay. At point Q, particle has 6, 7 coordinate t equal to 2. And at point R, particle has 13, 14 as coordinates at t equal to 5. Now we have to find the average velocity. First of all, the vector from O to P would be equal to R1. This would be equal to 2i plus 3j. Alright. Next, R2. The vector from O to Q. This would be equal to 6i plus 7j. And next would be R3. The vector from O to R. This would be equal to 13i plus 14j. So what I had earlier told you about average velocity. This is net displacement. You see, velocity is being considered here. Had it been speed, it had been distance. But here it is velocity. So we will take displacement over here. Net displacement divided by the time taken. So it is asking the average velocity from 0 to 5. Okay. So net displacement at initial point it was P. Net displacement means the simple straight line between initial and final point. So this is the net displacement. We'll have to omit q over here because the net displacement vector will go from straight from P to R. Because net displacement is a straight line between initial and final point, all intermediate points the particle may have covered will be neglected right now. Okay, so this was R1, this is R3, so PR would be the net displacement. This would be equal to R3 minus R1 according to triangular vector law. And so R3 was 39 plus 14j na? 39 plus 14j minus 2i minus 3j. This comes out to be 11i plus 11j. Alright, so net time taken was 5 seconds. So average velocity would be just simply dividing PR by the net time taken. This is 5. Okay, so this is average velocity. Alright, this is the average velocity. 11i plus 11j divided by 5. So you see over here, fourth option is our answer, because this is 11 divided by 5 times I plus j. Alright, so this is the answer. Alright. Okay, so this is the next question. We see this is similar to what I taught in my previous videos, one of my previous videos. The oscillation of a body on a smooth horizontal surface is represented by the equation x equal to a cos omega t, and omega is the frequency of oscillation, x is the displacement at time t. We are to construct graph of a versus t. Alright, I have done a question similar to this in one of my previous videos. Alright, this is the original question, x equal to a cos omega t. I have drawn a graph of this, x versus t. This is a typical graph of cosine, and you see at pi by 2 omega this turns out to be 0, at 3 pi by 2 omega, at 5 pi by 2 omega, but at 0 it is a. Cos function always reaches its maximum at 0. Okay, this is different from sine function which reaches 0 at 0. So now we have to calculate the graph of a versus t. So for this, first you differentiate this with respect to time, dx over dt. What will be this? A omega sine omega t. Alright, minus a omega sine omega t. Now this is v versus t graph. This is the velocity because change in displacement by time taken is velocity, sine omega t. Now we have to obtain a versus t. We again differentiate this, dv by dt. Change velocity by time is acceleration. So this would be equal to minus a omega square cos omega t. This is because you see differential of cos is minus sine and differential of sine is plus. So ultimately acceleration here would be negative. Okay, it will not be positive. Here minus has been obtained. So this, you see, this is again cos graph. So just the reversal of this would be the acceleration. Alright, I'll draw it in a separate graph. You see a over here is minus a omega square cos omega t, right? So we can draw it like this. This is t and this is a. Obviously this is positive and this is positive, but this is negative. At t equals 0, a would be equal to minus a omega square. So cos will start from here. Alright, and minus omega square will be the amplitude of this. Alright, the cos graph will never go beyond its amplitude. So it will start from here and like this. This would be the graph of cos. Okay, this would be pi over 2 omega. This would be 3 pi over 2 omega, and this would be 5 pi over 2 omega. This is the graph of acceleration versus time. Okay, so you see this is exactly what I've drawn, and third is our answer. Okay, you see it's starting from negative. It has to start from negative. Okay, because it is minus a omega square. Alright, so let's get to the next question. You see it's written that a projectile is fired from the surface of the earth with a velocity of 5 meters per second and an angle theta with the horizontal. Alright, another projectile fired from another planet. It is not the earth, okay, with a velocity of 3 meters per second at the same angle follows a trajectory which is identical with the trajectory of the projectile fired from the earth. Alright. This means if the trajectory is ideal, then the range should be same. Alright. And the value of acceleration due to gravity on the planet we have to find. Alright. So we have taken two different graphs of projectile. One is for Earth and one is for the other planet. This is 5 meters per second. We take this as O, take this as O dash, okay. And this can be X dash and this can be Y dash. So the angle is same. It is written. This is theta and theta. Trajectory is same. This means if this is point P and this is point P dash, so OP equal to O dash P dash. Because the trajectory is same, the range has to be same. And what was range? Range was, I covered the range in my previous videos. Please see them. Please see it. It was U square sine 2 theta, okay, by 2g. This was the range. Alright. So velocities are different, angle is same, and gravity is different. So this is OP U1. Alright. And this would be U2 square sine 2 theta by 2g dash, because the gravity is different. So sine 2 theta cancels out, 2 cancels out, and we are left with U1 square by g equal to U2 square by g dash. And g dash would be equal to, what is U2? U2 is 3. So 3 times 3, 9 into g. We assume g here as 10. And U1 square, what was U1? 5. So 25. So g dash is 90 by 25. Alright. This comes out to be 3.6 meter per second square. This is our answer. Okay. Yeah, and one more thing. Range is actually U square sine 2 theta by g. It is not 2. Okay. So L is U square sine 2 theta by g. Alright. So sine 2 theta will cancel out. Answer will be 3.6 only. Okay. Or any option near about 3.6 is the answer. Range is always U square sine 2 theta by g. Alright. It is not 2g. Alright. So in this question, the answer is 1 because it is near about our answer. 3.5 is the answer. Okay. Alright. So let's move on to this question. This is a very simple question. I am not taking complex because I have not taught you force right now. I will teach you force in the next 2 or 3 lessons. But this is very simple. All of you know force is change in momentum, rate of change of momentum. So this can be done. The force F acting on a particle of mass m indicated by the force time graph shown below. This is the force time graph. Okay. Change in momentum of the particle over the time interval from 0 to 8. We will have to calculate this. Alright. So this is the graph between F and T. One thing is that force is the change in momentum divided by time taken. Every one of you knows this. Why? Because momentum, actually force is m into dv by dt. dv by dt is acceleration. So we can take m inside the differential because it is constant. So dmv by dt, this would be nothing but dp over dt. Alright. So we have to take out the change in momentum. So dp would be equal to f times dt, and we can integrate this. You see, this is very similar to one of my questions which I did in one of my last videos, which was regarding displacement and distance. For example, if I consider a graph under vt, this is +1 and this is -1. If I have to calculate displacement, okay, this would be 1 minus 1, this would be 0. Why? Because sign is being taken because the displacement is a vector. If this was distance, this was 2, because this is a scalar. So similarly, since momentum is a vector, we will have to take the sign here. So simply f dt is obviously integration of two variables under graph gives the area of graph y dx. So this will give the area under graph, and hence this would be equal to delta p would be equal to 6 minus 6 plus 12, and this would be equal to 12 Newton second. This is the answer of change in momentum from 0 to 8 seconds. Okay, so here we see option 3 is our answer, 12 Newton seconds. 6 minus 6 plus 12 gives 12. So this third option is our answer. Okay, so now this is the next question. You have to read the question very carefully. A particle of unit mass undergoes one-dimensional motion such that its velocity varies according to u is given as a function of x, okay, equal to beta x to the power minus 2n, where beta and r are constants. Beta and r given as constants, okay. They are not varying, and x is the position of particle. Acceleration we have to calculate, okay. Okay, so this is the velocity and we have to calculate the acceleration. This is very simple because this is the velocity given, hence the differential in velocity with respect to time is acceleration, right? Now velocity is given here as a function of x, so we cannot take just time because time is not here. So what we do is dv by dt, right? We now multiply with dx and divide with dx, okay, multiplying and dividing. So we can take this expression dx by dt, alright. So this becomes dv by dx times dx by dt. We know that dx by dt is v, alright. So v dv over dx. This is the formula for acceleration, alright. So let's try it out. Du by dx. What would be du by dx? This would be equal to minus 2n, right? Beta x minus 2n minus 1, okay. And simply you multiply u here, alright. So we multiply u and we multiply beta x to the power minus 2n. So we get a equal to minus 2n beta square x to the power minus 4n minus 1, alright. So this is the answer. The second one is our answer, okay. Minus 2n beta square x to the power minus 4n minus 1, and here it is minus 2n beta square x to the power minus 4n minus 1, okay. So this is the next question. A block of mass 10 kg moving in the x direction with constant speed of 10 meters per second, okay. It is subjected to a retarding force F equal to 0.1 x joules per meter, okay, during its travel from x equal to 20 to 30. Its final kinetic energy. I'm taking this question because it is simple and it is just formula based, so there is no need of conceptual clarity over here because the intricate concepts of force and everything is not involved over here. Alright, so we see over here when the particle is going from 20 to 30, force is applied, and because the force is retarding, I have taken the force to be negative, and obviously there will be a deceleration instead of an acceleration, and the final velocity will be less than initial velocity, okay. So there is no need of conceptual clarity in what force is and you know other equations. Just we write F equal to m into a. This would be equal to minus 0.1 x, okay. Now as I earlier discussed, a was v dv divided by dx, right? This was minus 0.1 x. That's why I wanted to take this question, because a here will be v dv by dx. So simple it is. mv dv would be equal to minus 0.1 x dx, and now the limit is important, okay. So you see the initial velocity was 10 and final will be v, and v will be less than u, okay, because the object has decelerated, okay. So let's start. M by 2, integration of v dv will be v square by 2. I don't need to tell you that, okay. V square minus 100. Go and learn integration if you don't know this. And this would be from 20 to 30, okay, because from 20 force has been applied. From origin the force has not been applied. From origin the particle was moving at a constant velocity, hence there was no force. But when it reached x equal to 20, a decelerating force was applied. So the decrease in velocity will happen from 20, okay. So this will be x square over 2, and this will be from 20 to 30. This will be 900 minus 400. This will be 500 by 2. This means 250. This will be equal to minus 25, because 250 into 0.1 will be 25. Alright. And m here was 10. So we have 10 over 2, which means 5. into v square minus 100. Alright, and this would be equal to minus of 25, and this gets cancelled out. This will be minus 5, and here v square would be equal to 100 minus 5, that is 95. Alright, so v square equal to 95, v will be equal to root of 95. And what is root of 95? Okay, we don't need to take the root because we have to find the final kinetic energy. V square we have, and final kinetic energy would be equal to half m into v square. So v square is 95, m is 10. This means 95 into 5. This would be equal to 5 5 is 25, 5 9 is 45, 475. This is the answer, 475 joule. Okay, we will have to find out the final kinetic energy. This is 475 joules. Alright, and if we were to find out the initial kinetic energy, that would have been half into 10 into 100, and this would have been 5. So 500 joules. This would be KE initial, and this is KE final. So you see, the object has decelerated, the KE has decreased because it was initially 500, now it is 475 joules. Okay, so this is our answer. First, 475 joules is our answer. Okay, so now we move on. This is the next question. You have to read the question very carefully. I will keep on saying this because mistake is made by not reading the question carefully. People tend to skip the lines of question and thereby arrive at wrong answers. Okay, so it is given a ship A is moving westwards with a speed of 10 kilometers per hour, and a ship B 100 kilometers south of A, alright, is moving northwards with a speed of 10 kilometers per hour. The time after which distance between them becomes shortest is. Alright, we have to find out the time at which the distance will be shortest between the two. You can see the figure over here. A is moving westwards, V here is 10 kilometers per hour, and since A and B are traveling with the same speed, so we assume it as V. Okay, so now we have to find the distance between, we have to find the time at which the distance between them becomes shortest. Alright, suppose A moves a bit. For example, here was A and it moves to A dash. Okay, so in time t, hence the distance covered over here will be what? V times t. In that time, B must have also moved from B to B dash, and this is Vt, hence this will be reduced from 100 to 100 minus Vt. Okay, so this is the distance we have to calculate. A dash, B dash. This is north, this is south, this is west, and this is east. Okay, so now the distance x, suppose x would be equal to root under 100 minus Vt whole square plus Vt whole square. Okay, by Pythagoras theorem, 100 minus Vt whole square plus Vt whole square. Alright, so now in this type of graphs, suppose we have an xt graph and we are to find out the time at which x is minimum. This means the graph must have reached a minimum at some point of time, right, for x to be minimum. So we see when x is minimum, the slope of the graph is horizontal. This means when slope is horizontal, the slope is 0. So dx over dt should be 0 at x minimum. But this is not the whole condition, this is only a part condition. Alright, dx by dt is also 0 for maxima. For minima, you will have to see the condition of d square x over dt square, the double differential. You see this curve as a whole is pointing upwards. You see the arm of curves, these are pointing upwards. This curve as a whole is positive, as I told you in one of my previous videos about maxima minima. So the double differential has to be greater than 0. Then only the true condition of minima will be fulfilled. Alright, so now let's first check the first condition, dx over dt. This would be equal to twice of 100 minus Vt into minus V, go and learn differentiation, plus v square, alright, times 2t, right, divided by x. This would be 0. Okay, so 2 gets cancelled over here. Okay, and v will get cancelled. Alright, so this becomes 100 minus vt into minus 1 plus vt. This would be equal to 0. So this becomes twice vt equal to 100, right? Because vt twice vt minus 100 equals 0. Okay, so we get vt equal to 50, and what was v? V was 10, so t would be equal to 5. Alright, 5 seconds. T here is 5 seconds, but is it the time at which x is minimum? For that we will have to check the double differential also. Alright, the double differential we will have to check again. So x would be equal to root under 100 minus vt whole square plus vt whole square, right? So dx by dt is twice of 100 minus vt into minus v plus v square times 2t divided by x. Alright, we do again d square x by dt square. Oh man, this is this will become more complicated. Alright, so there are two variables now, x and t, right? So first we differentiate x. This can be assumed as alpha. The numerator we are assuming as alpha t, alpha as a function of t divided by x. Okay, so d square x by dt square would be equal to d over dt of this. Alright, and this will be equal to x d alpha by dt minus alpha dx by dt by x square. Alright, so since we have assumed numerator as alpha, and this whole expression you can do it yourself. Okay, try doing it yourself, this will waste my time only. And this whole expression, when you differentiate the above and the denominator below, d square x by dt square will come out to be positive. Okay, don't forget to put the value t equal to 5. Okay, when you have completed the double differential, do put the value of t and check, and this will definitely come out to be greater than 0. Alright, so this is the condition of minima, and hence our answer here for minimum distance is t equal to 5. Okay, now let's check. So you see, this is our answer, t equal to 5 hours. Actually it's hours because speed is given in kilometers per hour. I thought it was given in meters per second. It doesn't matter. Please take care of these things. And t is 5. Okay, here it is. Here is our answer. Okay, t equal to 5 hours. So this is our next question. A particle moves so that its position vector is given by r equal to cos omega t I and plus sin omega t j. Okay, these are unit vectors and we can take them as I and j. It does not matter. Which of the following is true? Velocity and acceleration are both perpendicular to r. Velocity and acceleration are both parallel to r. Velocity is perpendicular, acceleration is directed towards the origin. Velocity is perpendicular to r and acceleration is directed away from origin. Alright, so this is the question. Now for velocity, everyone knows we have to just differentiate this. dr by dt will be equal to v. This will be equal to minus omega sin omega t I plus omega cos omega t j. As it is given that omega is constant, so we can take this out and we have minus omega into sin omega t I minus cos omega t j. We have taken the minus sign also out. So we are to determine whether velocity is perpendicular or parallel to r. How do we do that? We simply take the dot product v dot r. Alright, so what will be v dot r? We just do the dot product of these two. We have minus omega sin omega t I minus cos omega t j. Okay, dot cos omega t I plus sin omega t j. Okay, so just I dot I is 1, sine omega t into cos omega t. So v dot r would be equal to minus omega whole sine omega t cos omega t. Now I dot j is 0, j dot I is again 0, minus cos omega t sine omega t, right? This becomes 0, cancels out, hence we see that v dot r equal to 0, and by the dot product, as I explained earlier, a dot b equal to mod a mod b cos theta, right? So since a dot b is 0, since v dot r is 0, we have cos theta equal to 0 and theta is pi by 2. Hence, v is perpendicular to r. Alright, v is perpendicular to r. Now, r was cos omega t I plus sine omega t j. Now we are to calculate the acceleration. A would be double differential of r, d square r by dt square. This would be what? First would be omega sine omega, and then it would reduce to omega square. Again this expression cos omega t I. Alright, this would be minus, and then again this would be minus omega square sine omega t j. Okay, so a would be equal to minus omega square cos omega t I plus sine omega t j. Alright, so this means a is equal to minus omega square r. So we see that if r is like this, this is cos omega t I plus sine omega t j, a is simply negative of r. This means a is directed along the center. A is pointed towards the center and velocity is perpendicular to r. Alright, a is just anti-parallel to r. Okay, there's no questioning that, because a dot r, we just calculate a dot r, we have minus omega square. This cos and cos will be cos square, sine and sine will be sine square, so cos square plus sine square, this means 1. Alright, so we see a dot r is minus omega square. Alright, so it is a constant value. Okay, this means a is anti-parallel to r. Alright, so a here is directed towards the origin and velocity here is perpendicular to r. This is our answer. So we see that velocity is perpendicular to r and acceleration is directed towards the origin, as I told you. So option 3 is our answer. Okay, so now this is our next question. It is written, a ray of light travels in the direction half I plus root 3j is incident on a plane mirror. After reflection it travels along the direction half I minus root 3j. We have to calculate the angle of incidence here. Okay, so this is the question. You see, we assume this as half I plus root 3j, and this is the first quadrant where both coordinates are positive. This is the second, this is the third, and this is the fourth. In fourth, only x is positive, y is negative. Alright, I want to clarify a few things here. First of all, this is the incident ray and this is the reflected ray. Always remember that angle of incidence equals to reflection angle. Okay, in light, first principle is this, and next principle is that these are measured from the normal also only. Okay, this is the normal to the mirror, and normal is always perpendicular to the mirror. And third point is, these all three, normal, incident and reflected ray, lie on the same plane. Okay, so I, R and N lie on same plane. So we are to find out the angle of incidence. So angle of incidence here would be the angle between incident ray and the normal, right? So this is the angle of incidence, alpha. And since the angle of incidence is equal to the angle of reflection, so this would also be alpha. And now we take the cognizance of the fact that these two are vectors. So just we compute the dot product of these vectors. So you see I dot r would be equal to I plus root 3j by 2 dot I minus root 3j by 2. So I dot r would be equal to what? So now I dot r would be equal to I dot I would be 1, I dot j 0, j dot I 0, root 3 minus 3. So minus 3 by 4. Okay. So 1 minus 3 by 4. This would be equal to minus half. I dot r is minus half. So I dot r obviously is mod I mod r cos theta. Alright. So this would be mod I mod r cos theta. What is mod I here? Mod I. So this is I incident ray is I plus root 3j na. So this would equal to 1 plus 3. Alright, by 2 the whole root. So mod I would be equal to 1 and mod r would be equal to 1 plus again root 3 the whole square, the root by 2. This would be equal to 1 again. So this would be equal to cos theta will be equal to minus 1 by 2. And when is cos theta minus half? When is cos theta minus half? Cos theta becomes minus half when 90 plus 60, when angle is 150. Okay, since cos of 90 plus 60, sorry, 120, 90 plus 30, cos A, cos B minus sin A, sin B, right? So this would be equal to minus half, right? 120. So angle between I and R is 120. Now, what is the angle between I and R? This is not the angle between I and R. Okay, the direction of vector we will have to take. We'll have to extend this vector. Alright, so this is the angle between I and R. Alright, this angle is 120 degrees. Some people will tend to take this angle as 120. No, this angle is not 120. Because had the direction of I been like this and R been like this, then angle would have been 120 here. But here direction of I is like this and R is like this, because I is going towards the mirror. So we will have to extend this vector and hence this is 120. So this is a straight line. This is 120. Then this means the whole of this angle will be 60. And 2 alpha equal to 60 and alpha will be equal to 30. So angle of incidence here is 30 degrees. Okay. So angle of incidence here is 30 degrees. Okay. A is the option and answer is written as A. Alright. So 30 degrees is the angle. We move on to the next question. It is given the position vector R of a particle of mass m. Position vector is given. It is varying with time as alpha t cube plus beta t squared j. Alright. Alpha is given, beta is given, both are constants, mass is given. So we'll have to see what option is correct. First, the option is given velocity v is this. Second, angular momentum L is this. Third, force is this. And last, torque. Okay. So these are only formula based, so we can do it. Alright, I'll be doing of just of velocity and force. Angular momentum I will be dealing later. Okay. So this is the radius vector given. Okay. Now we have to calculate velocity. It is very easy. We just differentiate it. So we will have here 3 alpha t square I. Alright, plus 2 beta t j. Okay. So values of alpha, beta, m and t are given. At t equal to 1 we will have to find out. So dr by dt at t equal to 1 will be equal to 3 alpha I plus 2 beta j. And what is alpha? 10 by 3. So it is 10 I plus 10 j. So velocity v is 10 I plus 10 j. Okay. So in option A, v is given as 10 I plus 10 j. So A option is definitely correct. Okay. Now we'll have to find the force. So this was velocity. Parameters are given. We just differentiate the velocity to get acceleration. dv by dt would be equal to 6 alpha t I plus twice of beta j. And at t equal to 1, it would be 6 alpha plus twice beta. and this is I, and this is J. Okay, this is I and this is J, right? So this is the acceleration, and for finding out force, we just multiply it with mass. Mass is 0.1, and 6 into alpha is 10/3 plus twice into 5. 3 into 2 the 6, 20 plus 10. Okay, so this would be I and this would be J. So 20I plus 10J into 0.1. F equal to 2I plus J. Alright, this is the answer, 2I plus J. So here force is given, F equal to I plus J. So C option is wrong. Okay, our answer is correct. C option here is wrong. So guys, this was my analysis of previous year's questions. Please like, subscribe and do comment. Okay, and this will be all for now. Thank you very much.